Chili burn. You take one bite of a red chili. Your mouth catches fire. Your face flushes. Sweat appears. Your nose starts running. You reach for anything cold. It is the first time tonight your body will completely overreact to dinner. But the pepper is not actually hot enough to burn you. So why are you sweating? The culprit is capsaicin, the chemical that gives chili peppers their kick. It presses a specialized pain sensor whose job is to warn the brain about dangerous physical heat. Capsaicin is a prankster with the alarm code. It pulls the fire alarm without starting a fire. But the nervous system cannot wait around to investigate. It sends a burning sensation, opens blood vessels in the face, and may trigger sweating as if the body needs to cool down. The nose can join in because the same irritation activates nerves around the mouth and nasal passages. Dinner has convinced the body it walked into a furnace. So you grab the obvious fire extinguisher, ice cream, and the rescue becomes the next attack. Brain freeze. The first spoonful feels perfect. The second hits the roof of your mouth, and a sharp pain suddenly stabs your forehead. But the ice cream never touched your brain. Doctors call this a cold stimulus headache. Rapid cold strikes the roof of the mouth and throat, where sensitive nerves and blood vessels react to the sudden temperature change. The message travels through the trigeminal nerve, a major sensory cable for the face. But the brain is not always brilliant at locating where a warning began. It can interpret that burst as pain in the forehead. Imagine one apartment pulling a fire alarm and the emergency crew racing to the building next door. The pain is real. The address is wrong. It usually fades quickly because the cold trigger disappears. Eating frozen food more slowly gives the mouth time to adjust instead of slamming the alarm all at once. The chili lied about heat. The ice cream confused the location of cold. Surely a room temperature piece of fruit cannot cause another crisis? Pineapple sting. You bite the pineapple. At first it is sweet. Then your tongue feels scraped, prickly, almost raw. Pineapple contains acid, but it also contains bromelain, a group of enzymes that break proteins into smaller pieces. An enzyme is just a tiny chemical tool. Bromelain acts a little like molecular scissors for protein. Your mouth is protected, and a normal serving is not digesting you alive. But fresh pineapple's acid and protein-cutting enzymes can help create that temporary stinging or tender feeling, especially after several pieces. For a moment, the snack seems to nibble back. Cooking or canning usually makes pineapple feel gentler because heat changes the shape of bromelain. Bent scissors do not cut as well. Now you want something that cannot burn, freeze, or bite. Cilantro soap taste. You try one harmless green leaf. Your friend tastes fresh citrus. You taste dish soap. Cilantro contains aromatic chemicals called aldehydes. Some aldehydes contribute to its bright green smell. Similar chemical notes also appear in soaps. Most people receive cilantro as an herb. But some noses turn up the soap channel. A tiny genetic variant near your odor receptors can turn up the volume on that soapy scent. Think of smell receptors as radio receivers. The song is the same, but one person's equalizer turns a hidden track all the way up. Genetics can tilt the dial. It does not write the whole review. Culture, familiarity, and repeated exposure can also shape whether cilantro becomes pleasant. That means two people can share the same plate and honestly eat two different realities. If you know the person who insists cilantro is soap, this is the moment to send them the proof that they are not imagining it. But what happens when you try to wash that soap taste away? Coffee bathroom urge. Desperate to wash the soap taste out of your mouth, you chug a cup of coffee. But the coffee skips the mouth entirely and rings a doorbell much farther down. Minutes later, your colon seems to receive a calendar invitation marked urgent. The coffee could not have traveled through the entire digestive tract that quickly, so it did not physically push yesterday's meal out like water through a pipe. Instead, the arrival of food or drink can trigger signals that increase colon movement. Coffee appears especially good at pressing that button in some people. In studies, caffeinated coffee increased colon activity compared with water. But decaffeinated coffee can stimulate movement too, so caffeine is not the entire story. Coffee contains many compounds, and the act of drinking it can join the gut-brain signals that tell the colon a new delivery is arriving. Imagine a restaurant clearing an old table the moment new guests enter the lobby. Not everybody responds. One study found the bathroom urge in roughly 3 out of 10 volunteers. For those people, the cup does not shove anything through. It rings the bell and the colon starts moving itself. But what strange receipt is waiting when you get there? Asparagus urine smell. That urgent coffee signal rushes you to the bathroom. Dinner has left a sulfurous odor from the asparagus you ate earlier. Your friend notices nothing. This disagreement can happen at 2 completely different stages. As the body breaks asparagus down, it can produce small sulfur-containing compounds that escape into the air. That is the scented receipt. But people appear to differ in how strongly they produce a detectable odor. They also differ in whether their nose can detect it. So, I do not smell anything does not necessarily mean my body made nothing. The receipt may be faint. Or, the reader may not recognize the ink. Research has linked the ability to smell asparagus urine with variation near a cluster of odor receptor genes. The vegetable changes the sample, then genetics can change the witness. 1 meal. 2 possible mysteries. Did the body write the message, and can the nose read it? But the next bathroom surprise looks far more alarming. Beet-red urine. Hours later, thanks to the roasted beets, the toilet turns a terrifying pink red. For an alarming second, it can look like blood. But beetroot carries deep red pigments tough enough to survive the digestive tract. Usually, digestion breaks pigments down or keeps much of them out of the urine. In some people, enough beet pigment survives the journey to color urine or stool. The pigment leaves the body still wearing its red coat. This harmless color change does not happen visibly to everyone. Differences in digestion and absorption can change the result. The same meal can paint one person's bathroom red and leave another person's unchanged, which makes the surprise feel even stranger. But red urine or stool should not automatically be blamed on lunch. If the cause is uncertain, keeps happening, or comes with pain or other symptoms, it deserves medical attention. But what happens when the body stops misreading a sensation and attacks the wrong visitor instead? Apple mouth itch. You survived the fake fire, the misplaced ice, the soap, and the fake blood. Exhausted, you reach for a simple raw apple for dessert. But this time, your body does not just sound a false alarm. Security arrests the wrong visitor. You bite a raw apple. Your lips tingle. The roof of your mouth starts itching. For someone with pollen food allergy syndrome, the immune system has learned to recognize a protein in pollen. But proteins in certain raw fruits, vegetables, or nuts can look surprisingly similar. The apple is an innocent visitor wearing the face of someone on a watch list. Security sees the resemblance and reacts. That is why the reaction often begins where the raw food touches, the lips, tongue, mouth, or throat. And it explains another strange clue. Cooking may change the shape of the problem. Protein enough that the immune system no longer recognizes it. The disguise falls apart in the oven. But this is not a party trick to test. Mouth or throat itching can be an allergic reaction. Trouble breathing, widespread hives, dizziness, or swelling can signal an emergency and needs urgent help. The pineapple's prickling and an allergic itch can feel confusingly close. Their stories are not the same. One can come from irritation. The other comes from mistaken identity. Now return to the first bite. The chili was not fire, but it knew the fire alarm code. The ice cream never touched the brain, but pain arrived at the wrong address. Pineapple brought molecular scissors. Cilantro changed with the receiver. Coffee rang the colon's doorbell. Asparagus left a scented receipt. Beets left a red one. And an apple borrowed pollen's face. These reactions look random only when we see the food. From the body's side, they follow one rule. Your body is not a perfect laboratory instrument. It is an anxious security guard working at incredible speed. It sees patterns, predicts danger, and acts before every fact is available. Most of the time, that keeps you alive. Sometimes, it makes dinner very weird. Share this with the person whose body reacts completely differently to the same food. And subscribe, because the stranger question is not why your body reacts, it is why someone else's barely does.